Welcome viewers, in this video we will see the Cartesian product, one of the topic available in mathematics under sets, relation and function. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we will go to the topic Cartesian product coming under set. So we know that the Cartesian product of a set is nothing but a set of ordered elements. This Cartesian product is nothing but set of ordered elements. In particular, Cartesian product of two sets is a set of ordered pair, while the Cartesian product of three set is a ordered triplet, right? So this is nothing but ordered element. Cartesian product mean. If the two sets mean, it is called pair. Three set means called a triplets, right? So let A, B and C be the three sets. Now we'll go for further analysis. A, B, C. We are consider that A, B, C are the three sets. The Cartesian product of A with B is denoted by A into B. It is defined by A into B equal to set of A comma B such that A belongs to A small a capital A comma B belongs to B. So this is the set, this one subset. Small letter refers the subset, A capital letter refers the set, right? So we consider three set A, B, C. In that first we consider the A into B. A into B is defined as a set of A comma B. In that A belongs to A. Subset A belongs to set A. Subset B belongs to set B. Similarly, the Cartesian product of A into B into C is defined by A into B into C equal to set of A comma B comma C such that A subset belongs to set A, B belongs to B, C belongs to C, right? So here we have three elements. So that thus A into A equal to A comma B such that set of A comma B such that A comma B belongs to A, right? So it is the correct way to say A into A equal to A comma A such that A belongs to A, right? So initially we have two set A into B, then three set A into B into C. So A small a refers subset, capital A refers set. So A belongs to A, B belongs to B, C belongs to C. In that case, suppose if it is A into A means A comma B, A set of A comma B such that A comma B belongs to A. Already we know that A belongs to A, B belongs to B. Now A comma B belongs to A. So in a correct way we can say that A into A equal to set of A comma A belongs to A, right? Now we'll go for the further analysis. It is important that the elements of the Cartesian products of ordered and hence for non-empty set, right? It is a ordered set, so there is no non-empty set. That is A cross B not equal to B cross A unless A equal to B, right? Unless A equal to B, A into B is not equal to B into A. That is for empty sets A into B equal to B into A if and only if A equal to B, right? If it is only A equal to B, then only A cross B equal to B cross A. We know that R denotes the set of real numbers. That is R cross R equal to set of X comma Y such that X comma Y belongs to real number R. R into R equal to set of X comma Y comma Z such that X, Y, Z belongs to real number R. Now we'll go for further analysis. Symbolically, R cross R can be represented as R square. Similarly, R cross R is represented as R cube. So R cross R is a set of ordered pair and R cross is a set of ordered triplet. We already know that 2 means it's ordered pair, 3 means triplets. What is that? If A equal to 1 comma set of 1 comma 2 comma 3 and B equal to set of 2 comma 4 comma 6, then A cross B is nothing but you have to multiply. 1 is multiplied with 2, 4, 6. 2 is multiplied with 2, 4, 6. 3 is multiplied with 2, 4, 6. So what available here? A cross B equal to set of 1, 2, 1, 4, 1, 6, 2, 2, 2, 4, 2, 6, 3, 2, 3, 4, 3, 6. Here A cross B is a subset of R cross R. So R cross R is the main set. A cross B is a subset. Only contain 1, 2, 3 here in A, 2, 4, 6 in B. So that is called a subset. Right? Now go for the further analysis. Thus, number of elements in A cross B is the product of number of elements in A and number of elements in B. Right? The number of elements in A cross B is the number of available products available in A as well as B. N of A cross B equal to N of A into N of B if A and B are finite. Further, N of A cross B cross C equal to N of A, N of B, N of C if A, B and C are finite. Right? So we can use this formula. We already said the number of elements A cross B is the product of number of elements in A as well as number of elements in B. Similarly here number of elements in A, B and C. It is easy to see that the following are the subset of R cross R. R is nothing but real number. We will see what are the possibility of subsets available for the real number. Set of x, 2x such that x belongs to R. So here x, 2x, right? X and 2 times. X, set of x, root of x. Here number square root. Such that x is the non-negative real numbers because we are going to take the square roots a non-negative real number. Set of x, minus square root of x such that x is the non-negative real number. Here we included negative outside of the square root, so not a problem. X, x square, set of x, x square is a number square of the number such that x belongs to real number R. X square, x, square root and normal number such that x belongs to R. Right? So the real number can be represented as one of few examples. Some more example also available. Number 2 times of number belongs to real number. Number square root of x belongs to real number in the non-negative real number. Number and square root of x with a negative sign outside is also non-negative real number. Number and square of the number belongs to real number. Square of the number and number belongs to real number. So in this video we discuss about the Cartesian product available in sets relation function, one of the topic in the mathematics. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.